This snake is the most interesting snake in all of mathematics. It represents a sequence. It starts up here at 0 and then snakes through 1, 1/2, -1/2, etc., etc. And you may notice the pattern that all the whole numbers, every single one of them is in the top row. Eventually the snake will touch them all. In the second row, those are all the fractions, positive and negative, where we have 2 in the denominator. And you also notice that there are lots of repeats. For instance, this number right here, 2/4, is the same as the number 1/2. And it's not filled in, but the number 3/6 is also 1/2. And that snake, you better believe, is going to go through that point too. This is part 16 of Let's Learn Real Analysis on TikTok. And this is a class where we really study numbers and sequences of numbers, and we look for the patterns that they have. I'll come back to the snake at the end of this video, but for now, let's look at a simpler example. Does this sequence converge to something? Does it have a limit? Well, no, it doesn't. It's not approaching any one value, but it does kind of seem that if we looked at only every third term, then every third term would be really close to 3. But if we started with the second term and did the same thing, every term would be really close to 4, and similarly with 5. And so that process where we're only looking at some of the terms, but still infinitely many, and still in the same order, that's something called a subsequence. Even though a sequence might not converge, for instance, here's another example, the whole sequence doesn't converge, but maybe part of it, or a subsequence of it, can. For instance, here, if we took every other term, that subsequence would converge to 0. We need this for our purposes for our next video, where we're going to be talking more about Cauchy sequences and why they actually have to converge. And we do that by looking deep into the guts of a sequence and see what's really going on inside of it. Now back to our snake. It probably won't surprise you to know that there's a subsequence of this snake that converges to 3. After all, the number 3 occurs infinitely many times, right? It's 3, but it's also 6/2. It's also 9/3 or 12/4. So we could go and we could circle all of those 3's as they occur, and we'd get a subsequence. But believe it or not, this snake has a subsequence that converges to the number pi. Another one that converges to the number e, and one that converges to the square root of 2, and one that converges to your social security number, whatever it is. That's because all of the rational numbers, in particular numbers like 3 and 3.1 and 3.14, which are all fractions, those all appear in the snake infinitely many times. And so there is a sequence that gets arbitrarily close and stays arbitrarily close to pi. I think this is a pretty friendly snake, but I do think it's a little spooky that this sequence contains inside of it, for any number you want, you're going to find a subsequence of this snake that converges to that number. Happy Halloween!